How do these fires destroy homes? Well, they destroy homes because the homes are leaky. They have these eaves for ventilation. If you have an eave for ventilation, the embers come into the house and then they burn the house from the inside out.
So, building performance is not just about comfort or lower bills, it's also now about whether buildings can protect people as climate risks intensify. Good morning, good afternoon, or good evening, wherever you are in the world. This is Climate Confident Stories and Strategies That Cut Emissions, episode 274, and I'm your host, Tom Raftery. My guest today is Darren Macri, co-CEO of Wythe Windows and rising president of the Passive House Network. In this episode, we're going to get into why Passive House is less about niche green design and more about cutting operational carbon, reducing energy poverty, improving indoor health, and making buildings more resilient during outages, heatwaves, and fires. So, I started by asking Darren what first pulled him into high-performance buildings. Darren, welcome to the podcast. Would you like to introduce yourself?
Sure. Thanks, Tom. It's a pleasure to be with you today. I'm Darren Macri, co-CEO of Wythe Windows and also rising president of the Passive House Network, which represents the Passive House International Standard here in the United States.
Okay, fantastic. And briefly, what drew you into the high-performance building space in the first place?
Well, I was a developer and builder, and I was building these buildings in Hoboken, New Jersey, and they're very nice. And I loved the creative process. I love working with teams. I love seeing something grow out of nothing and become a place where people are going to live and make memories. And I said, well, if I want to continue in this career, I want it to align with my values. And I remember I had this one moment back in 8th grade when our science teacher held up Time magazine and was telling us about global warming. And that just stuck with me from that moment on. And I said, well, okay, I want to build buildings and I love that process, but I want it to be more sustainable. So what can I do? And this is like 2006-ish. LEED was basically the leading sustainability standard at the time. And so I became a LEED AP. And I said, wow, that does a lot of nice things. It takes things into account like brownfield development and developing properties near transportation and encouraging bike usage. And so it has a lot of things under its umbrella. But because I was building in an urban environment, I'm like, well, really, I could be getting points for things that just happening naturally with my projects and still not really be building a more sustainable building, a building that really has a drastic reduction of its operational carbon. And so, but in 2009, I was at a conference in New York City, and there was a dais there with 3 gentlemen on it, and they were talking about this thing called Passive House. And I was like, wait a second, what is this? We can dramatically reduce the heating loads of our buildings by up to 90% by just making the building, by designing it and modeling it to be more energy efficient, not doing anything super crazy, but just being more thoughtful about it, making it a holistic practice. Well, it was like that moment in The Wizard of Oz where it goes from being black and white to color. And I was like, wow. And I wrote it down in my notebook. I said, I got to study this. And then I put the notebook down on my desk and like 6-7 months passed by. And I'm like, I left that notebook there. I opened up the notebook. I'm like, I got to do this. And so then I immediately enrolled in a class and I started studying Passive House and I became my Passive House consultant. And then I said, well, now I got to build one. And so then I started looking for the right property to build one. And so then I eventually built New Jersey's first certified Passive House. And you can't look back. Once you know and once you see it, you can't unsee it.
So for people listening, what is a passive house, as opposed to a house that meets LEED version, whatever certification? What's the difference?
Yeah. LEED takes a lot of wonderful things into account, such as brownfield development, being close to public transportation. Passive House is purely focused on the operational carbon, and of that, really, that heating and cooling load crushing that down. Passive house can reduce that heating load by up to 90% through its 5 basic principles. And it's that operational carbon that really makes up 40% of our national CO2 emissions. So if we can reduce that heating load and that cooling load dramatically, we can make a huge difference in our national CO2 emissions on a yearly basis. And so that's what is so dramatic about Passive House in terms of being a sustainable building standard. On the other side of it, you had, even if we solved global warming tomorrow, it's
Mm.
still important to build Passive House because it has incredible health and comfort benefits. So all these other benefits just cascade off of Passive House, from being a much better indoor air quality, much more peaceful home. So because the home is so super insulated, it's so much peaceful and quiet. You don't have these feelings of draft being in the home. So you're not sitting on your couch and throwing a blanket on you and saying, oh gosh, I feel chilly just sitting here. There's a nice even temperature throughout the whole house. So it's incredibly comfortable, resilient. We see a lot of passive houses surviving where other houses are failing in terms of wildfire, floods, and natural disasters like that, being able to shelter in place because the house holds the temperature for longer periods of time. So those are some other incredible benefits of passive house.
Okay. And just from a practical perspective, what's the difference between a passive house and another house? Is it more insulation? Is it using different materials? Is it, I don't know, you tell me, what goes into making a passive house?
Yeah, great question. And so, yeah, I'm telling you all these wonderful benefits, and you're like, well, how the heck do I do this? So it really comes down to these 5 basic principles. Airtightness. You want to make the house super airtight. Right now, we built houses, we actually designed them to be a little bit leaky so that they can bring in fresh air and extract the stale air in a way. And that's not a controlled way of doing anything. You want to make it super airtight, and then you can control your ventilation. Because why do you want it to be airtight? Well, you're conditioning that air. You're heating it in the winter, you're cooling it in the summer. So why put all that energy into doing that? Going to let it leak out to the envelope. So make it airtight. In New Jersey, where I'm at, they just did a big improvement to the code. Now we can be 3 air changes per hour if you measure the house's airtightness through a blower door test. 3 air changes per hour. A passive house leaks at a rate of 0.6 air changes per hour. So a dramatic reduction. And the thing is that most building codes have this standard in there, 3 air changes. I think some areas are 5 air changes per hour. A lot of jurisdictions aren't even mandating a test. So it's just self-verified. Then you really don't know what you have if you're not testing it. So a blower door test will help you measure that air leakage and make sure that you're building an airtight building. 0.6 air changes per hour. That's principle number 1, airtightness. Then climate appropriate insulation. So look at where you are. Look at the heating degree days that you have and put the amount of insulation you need. So now that you're not thermally losing that energy through the wall. My passive house, I have a wall of R35. And where did I put all that insulation? Well, that leads us to principle number 3, thermal bridge-free design. I put all that insulation on the outside of my building. So if you were to take a thermal image of a typical home, whether you build a 2x4, 2x6, whatever, and you just stuffed insulation between the studs, you would see, okay, the insulation's doing its job between the studs, but where the studs are, those are little thermal bridges, and they're radiating heat through those studs. So if you exterior insulate, you can eliminate those thermal bridges. So you want to have thermal bridge-free design. Other areas of thermal bridges are around that sill plate, the eaves that penetrate the envelope on homes. So you want to try and find out where it gets tricky to get that insulation. You want to have continuous airtightness and continuous insulation. When that building's airtight, we want that ventilation. So principle number 4, bring in fresh air, extract the stale air through mechanical systems. So you want to have mechanical ventilation. It's not just 2 fans running, bringing in fresh air and extracting stale air. There's a core in there. There's a membrane that recovers the energy. So you have your interior air at 68 degrees. let's say it's 0 degrees outside, this is Fahrenheit, you pass that conditioned air over the fresh air that's coming in, and through thermodynamics, the heat will run to cold and transfer its energy. And you can recover up to 90% of that energy. So now that delta of what you have to heat up is so much smaller. And you can do that with a much, much smaller mechanical system. The savings of putting in that smaller mechanical system allows you to put on additional insulation or buy windows that may be slightly more expensive, because that's principle number 5, high performing windows. That's one of the key principles, because the window is where every layer of your building envelope aligns. And it's part of your air tightness layer, it's part of your insulation layer, it's part of your heating strategy, because you want to capture that free heat in the winter time, that low summer sun, or winter sun rather. The sun is lower in the sky. We want to heat up the house on the south side, preferably. So we designed the house, preferably designed with 20% glazing on the south side to get that free heat. In the summertime, when the sun's higher in the sky, we could have eaves or deciduous trees that shade those windows and allow us to not overheat in the summertime. So the window is part of that heating and cooling strategy. It's part of that ventilation strategy, because windows open. So it's a critical component. It was through Passive House that I really discovered how the importance of windows. And when I built my New Jersey's first certified Passive House, I had to import my windows from Europe. And it took a lot of time. Things didn't come complete. I had to wait for things. And I said, how do I expect more people to actually build more of these high performing buildings if one of the key components is coming from 6,000 miles away? And so my business partner and I started Wythe Windows to manufacture these high performance windows and supply them to people who wanted to build more of these high performing types. With those 5 principles, that's how you achieve Passive House. So it takes a little bit more planning, but nothing I said really beyond mechanical ventilation and the windows is anything that we're doing different than today. The windows, well, we are putting windows in our buildings, but getting these particular type of windows, these European style tilt turn windows, which have more gasketing and more locking points than American style windows, and better, more insulated frames. So, we're already trying to make our buildings more tight here in the US, but it's about using more robust materials and planning that air tightness strategy. We already insulate our buildings. It's just about where you place that insulation, how much you use. It's just about learning and implementing and planning in a slightly different way. And it doesn't have to cost more. And we've seen that already with studies that we've done with the Passive House Network.
And are you just talking about new build, or what about retrofitting the existing stock?
Oh, retrofitting is a huge part of the Passive House movement, but definitely, of course, new build. And it's called Passive House, but it could be a grocery store, it could be a school, it could be a multifamily building, it could be office buildings, it could be single family home. So yes, new construction is huge. And even many of the codes are the stretch codes, like the stretch code in Massachusetts for new construction is basically the Passive House standard. So it is growing in new construction. However, retrofit has been a huge concern of the Passive House community, because we can build all the new Passive Houses we want, but if we're not taking care of our existing building stock, we're not going to be able to make that dramatic dent that we want to on operational carbon. And through my role in the Passive House Network, the state of New York set up a delegation to go and visit the Energy Sprong movement. This is back in 2018 in the Netherlands. And Energy Sprong is a fascinating movement that started in the Netherlands about overcladding buildings for affordable housing and keeping the tenants in place. And so that actually sparked a lot of ideas. How can we do this here in the US? I mean, the Netherlands has a very similar building typology. The US has a wider variety of typologies and much taller buildings. And I said, well, how do we industrialize the way we retrofit buildings? And so we've developed an overcladding system specifically for mid to high rise buildings for affordable housing. We build these panels in the factory. would go to site, you put these mounting cleats on the building, and then you hang this finished panel on the building. It's an all new facade. It's super insulated. It's got the window pre-installed, and they connect together to make an airtight, watertight building envelope. And so that is an exciting development that we're doing here at Wythe called Wythe Panel. But that's not the only way to retrofit buildings. And then there's a passive house standard called Interfit, which makes it a little bit easier to achieve the passive house standard if you're retrofitting a building, because we realize that there are a lot of challenges with retrofits. So many answers to that one question.
And what about then resilience? I mean, this is obviously hugely important. What changes when you think about passive house through a resilience lens, not just an energy lens?
And it's so pertinent right now because we see such dramatic shifts in the way weather patterns are. And these storms are so much stronger, and the cold snaps are so much colder and longer, and the heat waves are going to get hotter and longer. And so we have to figure out, how can people stay comfortable for longer periods of time, especially if there's outages in the grid or whatever the storm may be causing. The first thing is sheltering in place. In a regular building, the envelope is leaking, the envelope is under insulated. So the energy you've used to make the home comfortable, it's all leaking out. Well, now we're holding it in tight like a thermos. So if you had your thermos and you put ice in it, and you came back to it a few days later, and if it's a good vacuum thermos, you'd still see ice in it. The passive house is like that thermos. It's going to hold that temperature even when there's a power outage, and you're going to stay comfortable in there for much longer. But also, it requires a lot less energy to run. So you can design your passive house to flip a switch and just put on just the essential items you need for that and run it off a generator a lot easier than you would be able to have done with a conventional home. Now let's imagine you're in the path of that storm. You're in the path of that wildfire. And we saw this in California. Many of the houses that survived were passive houses or implementing passive house principles. How do these fires destroy homes? Well, they destroy homes because the homes are leaky. They have these eaves for ventilation. A passive house would be airtight, but if you have an eave for ventilation, the embers come into the house and then they burn the house from the inside out. Or if they have lower performing windows, then the thermal stress cracks the windows and then comes through the window and then once again burns the house from the inside out. With a passive house, your windows are going to be able to handle that thermal stress to a much greater degree, and you'll have an airtight envelope where embers are not going to be able to sneak into the house. And your home will be exterior insulated, ideally, and then that will also not allow the fire to damage the home.
How important are things like noise and indoor air quality, and is comfort, for example, underrated as a driver for adoption?
Oh my gosh, so true. It's like we're so used to being bullied by our buildings. I mean, we just take it for granted. Like, oh, by the front door, let's put this little stuffed snake pillow and hope that it stops the air. Or every couch has to have a blanket on it because you're going to sit down and you're going to have that asymmetrical heat loss. Your body is literally radiating heat to warm up the window, so to reduce the condensation risk of that window. We're so used to it, and we don't realize that there is a better way, and that we're allowed to be comfortable. We're allowed to not have cold surfaces. Your countertop, shouldn't be ice cold. That's built and baked in. It's central to passive house. We have something called the comfort criteria, and you can meet the thermal standard, but it's actually more difficult to meet the comfort criteria. If you don't meet that, you don't have a passive house. Where does most projects fail at the comfort criteria is because of that, the window performance. And you need to have a very insulative frame so that you don't run any risk of having any sort of condensation that builds up. And that's more than unsightly. That can lead to bad hygiene, because when you have warm, moist air in the house, hits a cold surface, the window frame, and then it condenses. That condensation rolls down and hits your drywall return or your wood trims, and that can lead to mold growth, and that can lead to bad indoor air quality, lead to bad health. And it's actually one of the most inspiring things about my business is that we actually do, believe it or not, our windows, they're high performing, sure. They're super elegant, absolutely. But we design them to be actually incredibly affordable too. Most of my business is in affordable housing. And one of the things that inspires me every day is that when they get installed into these affordable houses or affordable multifamily buildings, it's making such a huge difference in the quality of life for the occupants. And these folks, they may not even care or even know, or they may even be paying their energy bill, but they feel and love the difference immediately. And these rooms are typically small, so the beds are right up against the window. So they're not feeling all their heat coming off onto the window. They're in the urban environments and they're so much more quiet because of the multi-point locking system and the triple gasketing, all that noise outside. We do a lot of projects by elevated highways, and I have tenants who take videos of them opening and closing the window, and you can see the noise is unbelievable, and then they close it and it just trips away. There's no noise. And so now they're getting better sleeps because they're more comfortable, there's less noise. And guess what? In our urban environments here in the States, where do we see the most cases of asthma? We see them in urban environments. And why is that? Because of the poor indoor air quality, because we're not providing ventilation, because we have buildings where the windows are so leaky and the smog is coming in from those elevated highways, because the windows are so bad, they're condensing and causing mold growth around those drywall returns. And now with these silly little windows that just get replaced, we are changing that, and people are going to live more comfortable, more healthy lives, and hopefully make a difference in their lives. And we're making a big difference into reduction of energy usage. So,
and I got to think, particularly in affordable housing stock, the tenants in these houses or the owners of these houses, the energy bill has got to be a much higher proportion of their income than it would be for the likes of you and I.
so true. What a great point. And that's something that we've been advocating for as the passive house community for years. And it's something we need to get recognized by banks and lenders, is that passive house gives them more buying power. They can get more house. And that's for buyers. But then for renters, we're reducing rents, we're subsidizing rents, but we're keeping them energy poor by making them take that larger chunk of their salary for their energy usage. And passive house eliminates that. And so actually, and we talk about Energy Sprong, that was one of the financial models that they used to help finance the retrofitting of their buildings. They would say, okay, you're paying this much for your energy. We're going to put that into the retrofit. And then they guarantee the retrofit for 20 years. So, and they maintain it too.
Okay, fantastic. And so if the benefits are so strong, what's still blocking wider adoption?
It's really just comes down to, I think, education, training, comfort. We've seen at the Passive House Network that where training is given and subsidized by the government for architects, builders, developers to be trained in passive house, there's a huge uptick in training and then a huge growth and adoption of that building method. You can't do something unless you know how to do it. And it's not radical or difficult. It's just learning how to implement those 5 principles of air tightness, thermal bridge-free design, mechanical ventilation, high-performing windows, and climate-appropriate installation. Learning how to implement those, learning how they work together, learning the Passive House Planning Package, which is the tool we use to model the buildings. And then it's a slightly different sequence in building. So it requires planning. It requires looking. We're so used to in our environment and everyone in this built environment working in silos. And we really have to be thinking about how do we work and look at this building in a more holistic, more team-oriented fashion, because we all affect one thing, and that's the building at the end. we're all part of the air barrier team. The plumber can't come in and start making holes wherever he wants. The electrician can't come in. We're all part of the air tightness strategy, and we all have to see our role in it. And then also there's a third pillar of what's slowing adaptation is just businesses are used to working the way they work. We make money this way. It's dependable. And why should I change and take the risk of adding this new layer of this crazy thing on top of what my business model? And I respect that. I understand that. And I think there's two paradigm shifts there is that I think there's more market opportunity when you deliver better quality buildings. It's a chance for your business to grow and do that. And then the other is that where we've seen builders take on that challenge is also where we've seen greater development in code and greater subsidies in providing a building that achieves these standards. So that's why one of the biggest areas we see adaptation is in affordable housing for passive house.
And what role does regulation play in this? I mean, what if New Jersey, for example, where you're based, what if the New Jersey legislature mandated that all new house build had to be passive house standard?
That'd be great. I mean, what stops them from doing that? I guess they feel, would there be enough people and materials to take on that challenge of building every building passive house? Well, I mean, it would be an interesting switch to flip and see if it'd be a nice challenge. In the last 10 years, there's just been insane growth. And there has been movement in code. When I first got into this, it was 5 air changes per hour, and it was air tightness, and that was code, and it was self-verified. Now it's 3 air changes per hour. And I think Energy Star, and I could be wrong, is 1 air change per hour. I mean, you have to check me on that, but it's going down, right? And windows are getting higher performing. Energy Star windows are getting higher performing. So it's happening incrementally. Do I wish it would happen faster? Absolutely, because we're on a race, right? Everyone's been talking about 2030. Now we're about 2050. But we're on a race to not bake in the worst results of climate change. So the sooner we can implement these principles and improve our built environment, the better it will be for all of us.
A lightning round for you, Darren.
Sure.
Few quick questions, 1-sentence answers if you can. First up, lower upfront cost or lower lifetime cost?
Both. It can be. We saw with a study from the Pennsylvania Financing and Housing Authority that they gave incentives for passive house for their affordable housing. And we saw that it was a scattergram graph, and it was all over the map. Passive house wasn't the driver of the cost. There were passive houses that were less expensive than standard construction. There were passive houses that were more expensive than standard construction. But over hundreds of projects, it really did not pan out that, passive house was a premium. And I would say, if you're doing your first one, yes, go ahead.
Lightning round.
I broke the rules of lightning round.
We'll keep going. New builds or retrofits?
Both.
Both again. Okay. Comfort or energy savings?
Both.
Both. Okay.
Why? Yeah. Why? Let's have our cake and eat it too.
Love it. I love it. Speed or long-term performance?
I don't think passive house necessarily takes longer to build, especially now that you don't have the long lead times for windows now that we're making them here in the US. So there's no need to sacrifice. Yes, both.
Okay. Yes. What building habit needs to go?
Ooh, that's a good one. Now this is, is that building habit? Well, first of all, in the US, we have some pretty, sorry guys from the US, we have some pretty lousy habits. I'm tempted because of windows. I want to say get rid of flanges on your windows here in the US. But most important thing when we're talking about sustainable buildings is airtightness. It's even more, if you had to choose one principle, it's the airtightness is the one principle you really want to plant your flag in out of all of them. So I would say taking that air barrier, weather barrier extremely seriously and making sure you're building an airtight building envelope. And none of this like flopping building paper flying around in the wind that I see sometimes driving around.
Okay. And what's one idea in this space which is still underrated?
I'm going to take a different twist on this one, is that we can be the drivers of innovation, that we can come up with our own solutions here in the US and make our buildings more energy efficient so that we don't have to get exotic equipment from overseas or rely on fancy materials coming from overseas. We can be the drivers of our own future and innovate mechanical systems that are more energy efficient, high performing windows in your own factory. We can be our own innovators of the solutions that we're looking for.
And a left field question for you. If you could have any person or character, alive or dead, real or fictional, as a champion for Passive House, who would it be and why?
Wow. It's a tough question right now because, you'd want to look for someone who's a great uniter, because really Passive House doesn't have a political divide. It really shouldn't be on any side of the political aisle, because I think we all are concerned about health and comfort, and everybody likes to save money on their energy bill. As we say here in the US, it's not a red state or a blue state thing. So often sustainability finds itself as something the blue state people care about, but really it's important for everyone. So who is that one person that would be the great uniter? The sad thing is, I think I'd have to go back to Abraham Lincoln. I don't know.
Okay.
I don't.
Great orator. That would work. Yeah. Super. Darren, we're coming towards the end of the podcast now. Is there any question that I didn't ask that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
I would tell you that if you are in the US, there's the Passive House Network Conference coming up on June 4th and 5th. It's going to be at the historic Hotel Marcel in New Haven, Connecticut. It was designed by Marcel Brewer. It's a brutalist building, and it was retrofitted to a Passive House. So that would be a lot of fun. I'll be there, and there's great pizza there. You got Frank Pepe's, Sally's, Modern, all some of the best pizza in the US right within walking distance. I don't know if anything else. I mean, I did babble on a lot. Your editor will have a challenge in front of them. I hope it was all right.
It was great. Super. Darren, if people would like to know more about yourself or any of the things we discussed on the podcast today, apart from the conference, where would you have me direct them?
Well, contact me on LinkedIn, Darren Macri, and then also check us out at Wythe Windows. I'd love to help you make your home more energy efficient with our USA-made high-performance windows.
Are all of your windows triple glazed?
Well, no, actually, we do a fair amount of dual glaze and triple glaze. Our dual glaze is still extremely high performing because we put it into our regular Passive House frame. And so it has that triple gasketing. It has that 6 thermal layers to give it great thermal resistance. And then we can design a dual pane as low as 0.20, which is quite low for a dual pane. And then our triple panes go much, much, much lower than that, obviously. But I would also say that one last thing about windows is that tilt turns are much different. Not a lot of people in the US know about what the heck a tilt turn window is and what makes a high performance window. And a tilt turn window has multiple point locks, and they go around the whole frame and sash. And so it makes it an even compressive airtight seal. So the same window that in the US, which would like a double hung or casement window would have one locking point, ours would have 6 to 7, maybe even 8 locking points going all the way around. So it's super secure, but then also all those locking points make it grab in nice and snug and airtight. And that's why we make tilt-turn windows.
Perfect. Great. Awesome. Dan, that's been really interesting. Thanks a million for coming on the podcast today.
My pleasure. It was so much fun, Tom. I appreciate the invite so much, and I'm here for you if you ever need me again.